Hi. In the previous example, we looked at example 28 from page 99 in the study guide, where we were asked to find the derivative of capital F of x, and where f of x was defined in terms of an integral with the lower limit 2x and the upper limit of 3x squared of the function cos of t with respect to t. We did that the long way around, and I mentioned that we can use the fundamental theorem of calculus to simplify this process a lot. Now, the first thing we did was we split up the integral between 2x and x cubed. We split that into two integrals, where we had the first integral being between 2x and any constant a, and then the second integral being between constant a and 3x. And then we inverted the limits of the first integral by putting a minus sign in front, and now we had f of x being equal to two integrals between a constant and a function of x. And then we proceeded with the long solution. But the fundamental theorem of calculus can help us out with this problem. Firstly, when we talk about the fundamental theorem of calculus, what it says is that if you have a function denoted by the capital F of x, which is defined as the integral between a and x of a function of t dt, and we take the derivative on both sides. In other words, we have d by dx of f of x, which would then be equal to f prime of x, and then we take the derivative on the other side as well, integral between a to x of f of t dt. And the fundamental theorem of calculus then says that this is equal to the small f of x. And if you look at the previous videos on the website, it explains this very clearly. Now let's apply this fundamental theorem to solve our problem. So we would then have f prime of x, and now we are basically coming from this line here is equal to do this, all we need to do is we substitute the x for the t. So we have minus cos of x, and we have, cos of 2x. Right. And then we need to add the derivative of the 2x, which is 2, and then we add the second integral, which is the cos of x cubed, and we need to multiply that by the derivative of x cubed, which is 3x squared, and that rewritten gives us 3x squared minus 2 cos of 2x. Oh, I left out the cos here. Let's redo that again. It's 3x squared cos of x cubed minus the 2 cos of 2x. And there we have the same solution as we did previously. Alright, and the reason why we needed to add this here is due to the chain rule, which we saw in the previous method that we did. We saw it when we took the derivative of this whole square bracket and we took the derivative of 2x, which is the cos of x, and then this was the derivative of the 2x. The same with the second one, where this is the derivative of the sine of x cubed, and this is the derivative of the x cubed. So that's where these two applications of the chain rule comes from. So what you will quite often see is that this function in here will be a difficult function to integrate, and you'll think, how can I possibly integrate that? But by applying the fundamental rule or the fundamental theorem of calculus, you circumnavigate that difficult step of having to integrate this difficult function. And some of the following examples will have difficult functions, and we'll see how we can avoid the integration step in those.